Come. Ordering of fractions. Very good. So this is the 6th week of our mathematical series. So GSS 1 first term scheme of work. We are following the topics arrangement in the scheme of work. So today's class will be dealing with ordering of fractions. This is the first subtopic under fraction that we'll be doing in week 6 based on the arrangement of your syllabus. Now, what does ordering of fraction mean? In a simple language, ordering of fraction means arranging fractions. So we can arrange fractions in order of size. So whether from the biggest to the smallest or from the smallest to the biggest. Remember when we were dealing with whole numbers, we also came across ordering of whole numbers. So I dealt with that. If you can go back to the video and see how we arrange whole number. That is very simple. The way we arrange whole numbers is not the same as the way we arrange fractions. So let me write the simple definition. Ordering of fractions simply means arranging fractions in order of size. So now we can arrange fraction in order of size. So from what I just said, we have two types of arrangement. So types of arrangement. Or order. So we can either call it arrangement or order. So we have the ascending order, and then descending order. So ascending means when something is going up. So just like when they say the man is ascending the mountain, he's going from the bottom of the mountain to the top. That is, he's climbing the mountain. So that means ascending, if we bring it to the concept of mathematics, it simply means when you arrange from the smallest to the biggest. That is, smallest to biggest. So that means this will be the opposite. That will be from biggest to smallest. So that is just the difference between the two. So arrangement from smallest to biggest means ascending order. But from biggest to smallest simply means descending order. So however, before we can deal with multiple fractions, many fractions, we need to first deal with two fractions first. Let's see how we can compare between two fractions and know the bigger and the smaller fractions. So let's see. I can clear this off. So let's compare between two fractions. That is a very simple thing. We are dealing with ordering of fraction. Don't forget. I mistakenly cleaned the topic. So now we need to first learn how to compare between two fractions. If you have 2 over 5 and we have 7 over 8. So if the question says you should see which one is bigger between the two, which is bigger? So question can ask which is bigger. Sometimes they say which is smaller. They use their English like this. Now, instead of wasting time on something like this, there is a lot of tricks that you can use. So there is a lot of method. Don't forget I said equivalent fraction method. If you go back to the last video, you can use equivalent fraction method. But that is a waste of time. So nowadays, teachers will have no choice than to mark the simple method that students use. Because nowadays, everything is just running fast. Nobody wants to nobody wants to say long story anymore. So, but that doesn't mean we should not teach the right way. But let's first of all see the trick in a simple way. So, if you want to compare between this and this, what you just need to do, just multiply the denominator of this with the numerator of this. So, this will be 8 times 2. 8 times 2 will give you what? That is 16. You have 16 upon this. Then you can multiply this and this. 5 times 7, that will give you 35. So we have 35 on top of this. Now, where do we have 35? 35 is corresponding to this. So that means this fraction is bigger. Therefore, 7/8 is bigger. So you can't judge by just looking at fractions. Some of you will think because this one has bigger number. It doesn't matter. It doesn't mean that it is the biggest. So let's see another example. Let's say we have 1/2 and we have 6/20. Now we have 1/2 and then we have 6/20. So let's see which is bigger between these two fractions. So for somebody that is not familiar with fraction arrangement, people will quickly jump and say 6/20 has to be the bigger, but that doesn't mean this has to be the bigger. So that doesn't mean this must be the bigger. So how do we do that? We just have to use the method. Multiply this by this and multiply this by this. If you multiply this by this, that means this has to be what? 20. It is 20 times 1, that will give you 20. Then 2 times 6, that will give you 12. So now look at it. For somebody that has rushed and said this is bigger, so you will see that the person will fail the question. 20 is bigger than 12. Therefore, 1/2 is bigger. Therefore, 1/2 is bigger. So that is how you can compare between two fractions. And if they ask you to select which one is smaller, you just say 6/20. You can use the same method. So 6/20 has to be the smaller, since this one is the bigger. Very good. Now, let's now see how we can deal with more than two fractions. More than two fractions. First of all, the method that we use in in arranging fractions from smallest to biggest or biggest to smallest is method of equivalent fraction. We still have another method by method of decimal. So we can use method of equivalent fraction. We can use method of decimal. So next, we can use converting to whole number method. So I'm going to use these three methods to solve just one question, and then we say bye-bye to this particular concept. Let's start with, for example, if question says arrange in ascending order. So you know that ascending order means from the smallest to the biggest. So question now says you should arrange 2/3. Come on. You should arrange 3/8. Next, you should arrange 1/4. Next, you should arrange 5/6. All these fractions, you want to arrange them in ascending order. Don't forget, ascending order means from the smallest to the biggest. Very good. Now, if you want to use this method 1, all you need to just do is convert all of them to have the same denominator. So that's equivalent fraction method. So, and you cannot do that unless you get the LCM of everything. We have 3, 8, 4, and 6. I can simply just draw a table here, put 3 here, put 8, the next, you put the denominator. 8 is the second denominator, 4 is the next, and then 6 is the next. So find the LCM of all of this. So of course, 3 can go in this and also in this. You can bring 3 first. This will be 1. 3 cannot go in 8, write 8. 3 cannot go in 4, write 4. 3 can go in 6, write 2. Very good. Now 2 can go in this 3. So I can bring 2. This one is already balanced. 2 in 8, that will give me 4. 2 in 4, that will give me 2. 2 in 2, that will give me 1. Now, 2 can still go in both. I'll just bring 2. This one are satisfied. These 2 are satisfied. So 2 in 4, that's 2. 2 in 2, that is 1. I think that's done. We are done with that. So, you can now bring 2 again. This is 1, 1, 1, 1. Therefore, LCM equal to, yes, this is 2 times 2, then 3 times 2, 6, 6 times 2, 12, 12 times 2, 24. So the LCM is 24. Keep this LCM because it's going to be useful throughout this method. Even the third method, so it's going to be useful in the third method. I'm going to do the first method and the third method, then I will do this one separate. Now, how do we now change this to equivalent fraction such that the denominator will be 24? All you need to first do is to divide 24 by 2. Divide 24 by 2. So, by 3 I mean, by the denominator which is 3. So 24 divided by 3, that will give you 8. So that means 8 will be the scale factor. You use 8 to multiply the top and the bottom. So that means this will give you, since you have divided 24 by 3 and you have 8. So use 8 to multiply this and use 8 to multiply this. This will be times 8 times 8. So 2 times 8 will give me 16 over 3 times 8 will give me 24. So of course, all the denominator will be 24. 24. And the last one too will be 24. All of them will be 24. So now, if you divide 24 by 8 here, you have 3. So now use that 3 to multiply the top. That will give you what? 3 times 3, that will give you 9 here. Now, we already have 24 as the denominator of the third one. This is the third one correspondingly. How many 4 can I get from 24? That will be 6. Then use that 6 to multiply the numerator. That will give me 6. Next is 6. So use this 6 to divide 24. That will give me 4. Then use that 4 to multiply the top. 4 times 5, that will be 20. So now, from what we can see here, so correspondingly, so the fraction with 6 over 24 happens to be the smallest. The fraction with the smallest numerator here among this one is the smallest, while the one with the biggest numerator is the biggest. So if we are to arrange, we see that 6 over 24 corresponds to 1 over 4. That means the arrangement goes thus. This will be my arrangement. I will start with 1 over 4 is the smallest, followed by what? Okay, followed by 9 over 24, which corresponds to 3 over 8. That means 3 over 8 is the next. Then, after 3 over 8, which is corresponding to 9 over 24, 16 over 24, which is 2 over 3. We can claim this as 2 over 3. 2 over 3. So next is the last one, which is the biggest, 20 over 24, which is 5 over 6. So this is 5 out of 6. So this is the arrangement in ascending order. If the question wants descending order, that means you have to start with 5 over 6, then come down till you get 1 over 4. That is descending order. So this is how to do this method. Very good. Okay, I can rub this off. Let me rub this off. Then, don't forget the LCM that we got is 24. I want to use this part of the board. LCM equal to 24. So, let me divide my board. I want to write out the fractions again. So let's write out the fractions. So we are dealing with method 2 now. Oh, sorry, method 3. I want to go to this before I come to this. So method 3. So for the method 3, okay, let me rewrite the fractions again. So we have 2 over 3, comma, we have 3 over 8, we have 1 over 4, then we have 5 over 6. Very good. Now, these are the fractions. So converting to whole number method. So I'll pick the first fraction, which is 2 over 3. Then I'll multiply it by the LCM, which is 24. So if you multiply that, of course, this will be 2 times 24. This is how to multiply. 2 times 24, that will give you what? 48. Then 48 divided by 3 will give you 16. That's for the first fraction. Then for the second fraction, this is 3 over 8. Okay, the second fraction is 3 over 8 times the same LCM. Multiply by the LCM. So here, I'm going to have 3 times 24, which will give you 72. Then you do 72 divided by 8, that will give you 9. So this is for the second fraction. Now for the third fraction, 1 over 4 times the LCM, which is 24. So instead of wasting time sometime, you just have to cut 4 here and 4 here, 6. Or you just do 1 times 24, that will give you 24. Then 24 divided by 4, that will give you 6. You can still go like that. Lastly, we have 5 over 6 times the LCM, which is 24. So over 1. You can say 5 times 24, that will give you 120. Then you do 120 divided by 6, that will give you 20. Now, from what we have here, the one with 9 is the smallest. This has to be the smallest. The one with 9 has to be the smallest. Oh, sorry. The one with 6. There is one with 6. We have 6. We have 9, we have 16, and we have 20. So 6 has to be the smallest here. Which fraction does it correspond to? That's 1 over 4. That means 1 over 4 must come first. Next, I check the one with 9. What does it correspond to? It corresponds to 3 over 8. I have 3 over 8. The next one here is the one with 16. 16 corresponds to 2 over 3. I'll write 2 over 3. Finally, the 20 corresponds to 5 over 6. I'll have 5 over 6. So, this is how to arrange fraction in order of size. This is ascending order from the smallest to the biggest. So, this is the second method. So, you can choose many other questions from your book and use this method. Now, the third method is convert